From our previous video, we have assembled our car chassis and we also made electrical connections for our components. In this video, we will test this hardware. We will program our Arduino Uno and perform quick testing of our DC gear motors. For this, we need Arduino IDE. I already have downloaded in my system, but if you do not have this Arduino IDE, then go ahead and download this from official Arduino Uno website. Here we will write our code. So first of all, let us talk about the pin configuration. So how I connected my L298H bridge to my Arduino Uno. From this picture, we can see the enable pin for my left side motor is connected to the 5th digital pin of Arduino Uno, and high and low pin for left side motor is connected to the 6th and 7th pin of Arduino Uno. In the same way, the enable pin for my right side motor is connected to the 10th pin of Arduino Uno, and low and high pin for my right side motor is connected to the 8th and 9th pin of Arduino Uno. Again, you have to remember we will control the speed of our DC gear motors with the pulse width modulation. So make sure the enable pin for left and right side motor should be connected to the PWM pins of Arduino Uno. So first of all, let us define the pins here. I will give a name to my pins. I will start with a constant int. First, let us give a name to our enable pin for my left side motor. So the name will be, let's say, enable L. And this pin is connected to the 5th pin. Next, same constant int for the high pin for my left side motor. So the name will be high L. This pin is connected to 6. Same for low side pin. The pin name will be low L. And this pin is connected to the 7th pin of Arduino Uno. Now these are the pins for left side motor, so I will write a comment also. Now in the same way, I will define for my right side motors. I will simply copy and paste it here. This will be for right side motors. Now let's change the pin name and pin number. So this will be enable R, this will be high R, and this will be low R. Next, the pins. So this is connected to the pin number 10. This is connected to the pin number 8, and this is connected to the pin number 9. Now next step, we have to define the pin modes. So all of our pins are output pins. So I will define the pin mode in the void setup. Alright, so pin mode is done. So in the next step, we will create a different functions for our forward control and for our backward control. So let's make a function for our forward control. So void forward. In this function here, I will write a code to run our motors in the forward direction. So I will use a digital write. First pin will be our high L. Here I will define the logic. Next, digital write. Now for our low L pin. Here I have to fill the logic so that my motors will run in the forward direction. So I already have tested these motors. So if I send low signal to this high L pin and high signal to this low L pin, then my motors will run in the forward direction. So I will send the logic here. This will be low. And for my low L pin, I will send the high. Now this logic may be different for your application, so you have to test your motor so that you can find the logic. Next, I will write a PWM. So I will use an analog write. I will send a PWM to the enable pin. So enable L. Let's say for the full speed, I will write a preset of 255. Next, I will copy and paste for my right side motor. Change here as high R. This will be our low R. And this is enable R. Now in the same way, I will write a function for the backward operation. So just copy and paste the forward function. Change the name to the backward. For this project, I will not use a backward function, but anyways, I will write the code just for demonstration purposes. For the backward operation, I have to reverse the logic. So I will send a high signal here. Instead of high signal, I will send a low signal here. Now same for our right side motors. Just reverse the logic. Alright, so our basic program template is ready. Now we can test our forward function. I will call the forward function in the void loop here. Now let's compile the program. First I have to save. So I will save this program as, let's say, test. Alright, so compilation is done and we don't have any error. Now I will connect the USB cable to my Arduino Uno and I plug it to my laptop. First of all, make sure you remove this external power supply from this power bank. Next, I will connect this USB cable to Arduino Uno and I will plug it to my laptop. Once you have connected your Arduino Uno, then we have to set a couple of things. Just go to the tool. First, we have to set the right type of board. I have Arduino Uno. Next, I have to set the port number. So my Arduino Uno is connected to the COM port 5. And now I can flash this program into our Arduino Uno. Uploading is done, so let's test in real environment. Again, connect this external supply from this power bank and turn on your power bank. Seems perfect. Now it's moving forward. We have tested this forward function and it works well. And the same way, go ahead and test this backward function also.